This is a 1.3-inch I2C OLED display, and today I'm going to show you how to use it. To make our building a little easier, I went ahead and made a stand for the display using an Iron Man, a Skywalker, and just some random Lego parts. If you look across the top of your OLED screen, you should see 4 pins. The first one, G and D, is just your negative pin. VCC is your voltage in. SCK is your serial clock. This synchronizes data between the microcontroller, in this case the Arduino, and the display. And then the fourth one, that is our serial data. This pin carries the actual data being sent from our Arduino to our display. So together, the SCK and the SDA, they make together the I2C protocol. And that's what this uses to send, display, and refresh data on the OLED. Now I've gone ahead and taken the OLED out of its little holder for now for this step because the holder honestly makes it a little hard to work with. So we're going to flip to the back of our OLED where we see our pins, and we're going to take the female ends of our connectors and we're going to try to slot them all on there at the same time. So let's go ahead and see if we can do that. And there we go. They are all slotted on. There we go. And we have different colors so we can know what we're doing. Over on this end, you have your male pins. So let's go ahead and connect those. I've went and split my connectors into 2 groups. The first group, as you can see right here, maybe if I can focus. This first group is our ground and our voltage. And that's just saying as a black and a white wire like that. The second group is our I2C cables. So our clock and our data line. Okay, so now with our black wire being our ground wire and our white wire being our live wire, we're going to go ahead and plug our ground wire in first. And then we're going to plug in our 5 volt. Now generally, you don't want to plug in your 5 volt or your 3.3 volt until you have the circuit built. But because we're not really plugged in right now, I'm okay with it. But if you are plugged into a computer or a power source and your Arduino is powered, be sure that you unplug your 5 volt before you unplug anything else. Failure to do so could cause shorts in the board if you were to touch the board with the exposed ends of another wire that has current running through it. Okay, now that I have those plugged in, let's go ahead and look at our SCK and SDA cables. My purple one is my SDA cable, and my white one is my SCK cable. So I'm going to plug the purple SDA cable into analog 4. Then I'm going to plug my SCK cable into analog 5. And that's it. That's the wiring. So now that it's all wired up, I've went ahead and put it back in this makeshift Lego container that I made for it. And now it's time to plug it in. Even though we have everything wired up properly and we have current running through our OLED, we can see that our screen is still black. Nothing's lit up. If we're using a regular LCD, at this point, it would be really bright. The answer comes in the form of the pixel. So in an OLED, each pixel is like a tiny little light bulb. Unlike the LCDs, OLEDs, they don't need a backlight, so each pixel generates its own light. What this causes is very bright, colorful colors that are fun to look at and sharp and provide really good images. And at the same time, the pixels that aren't on are truly off, so they're actually black. They're not some fake generated black by electricity. They are black because they're just not on. Now that we have our hardware set up, let's go ahead and code it. We're going to be using a library called U8G2lib, and what that does is it's a library that allows for easy interaction with OLED displays. So in your Arduino IDE, if you look over on the left side, you should see a file and a whole bunch of this stuff, and then you should see something that looks like stacked books. We're going to click on that. And inside the search, we're just going to search U8G2. And the one that pops up will be by Oliver. It says monochrome LCD, OLED, and e-ink library. That's exactly what we want. So we're going to install that. We'll get this little confirmation that it's installed. Cool. Click on the library icons again to close it. And we're going to go ahead and clear our terminal and drag it down a little bit. So after you've installed the library, the first thing we want to do is go ahead and include it in our code. So I'm going to go up to line 1 and press enter a few times just to get us some space to work with up here. And we're going to say hashtag include. And we're going to import the u8g2 lib.h. Cool. Let's throw in a comment. We'll just say that this imports the needed library into the code. All right. Now, this next part, it's kind of long and drawn out, but stick with me here. So we're going to initialize our OLED display using a certain controller with the hardware that is using the I2C protocol. So we're going to just say, in all caps, U8G2 underscore SH1106. That's the controller that we're going to be using. I just realized now that my caps lock didn't turn on. So on line 3, what I'm going to add is some initialization code that lets the code know that I'm working with an OLED display and what controller I'm going to be using, along with what size and how big our memory buffer should be. So we're going to start just by stating our library, U8G2. And I have my caps lock on this because this is in all caps. You're going to say underscore SH1106. That is the driver or the controller that's going to be controlling our OLED. Next up, another underscore. We're going to declare the size of our OLED. This one is a 128 by 64 size display. Then the next thing, if your OLED comes from a notable or branded manufacturer like Adafruit or something, you would put the name here, but ours is generic, so we're going to say no name. Then another underscore. We're going to put F for our full memory buffer. What this will do is it will allow us to access more of the RAM on board the Arduino, but the downside of that is that it will also allow us to access more of the RAM on the Arduino, so there won't be as much left for other things on the Arduino, because it will all be prioritized toward our OLED, but that's okay for now. So we're going to say that our hardware, HW, is using the I2C protocol. And that's the hairy bit. I'm going to turn off my caps lock. And then we're just going to call on U8G2 again. And while I'm here, I'm going to highlight this and copy it, because we're going to be using this quite a lot, and I don't want to type U8G2 because it's weird and gross to type, honestly. So I'm just going to copy it to my clipboard. All right, after that, we're going to open parentheses, and in all caps once again. Oh, I pressed the wrong button. In all caps once again, we're going to write U8G2 underscore R0, comma, and then U8X8 underscore pin underscore none. What does this part of the code do? Man, that is a great question. I have a feeling it has something to do with the resistor, but it's whatever. We don't need to know everything. Alright, and that's it. That's the most complicated line of code. Well, one of the most complicated lines of code that we'll have in here. So we have our pre-setup set up. Let's go ahead and go down to our setup. So this is where majority of our code will take place, unless we want to add a button or something later on, in which case we would use the loop. But to just get something displayed here on our OLED, we're mostly just going to use the setup. So we're going to paste our U8G2 and say .begin. What this is going to do is this is going to start communication with the OLED. That's it. It begins communication. Now, whenever we wrote this F, we talked about how there's memory allocated for the OLED, and every time we send something to it, we want to kind of be sure to make sure that we're not overriding any memory things. So one way to do that is just clear the memory. So we're going to paste U8G2 again, and we're just going to say clear buffer. This is going to set up our memory such that it is clear, there's nothing there. We can just kind of throw something at it and it won't cause any issues with memory or whatnot. So we're just going to clear the display. Okay, so the second most complicated line of code in this has to do with the font. So we're going to press Control V to paste this, or Command V if you're on Mac, and we're going to say set font. Now the fonts, they're built into the library and they're weirdly named, so just bear with me for a bit. I will put a link to the repository for this, and I'll also put a link to specific things such as the font list and the command list for this display using the U8G2 library. So inside these parentheses, we are going to do U8G2 underscore font. So we're accessing the font in the library, and this one is called NCEN B08 underscore TR. What a loving name. I also just saw a mistake I made up here on line 7. I didn't put my semicolon. Be sure that you put your semicolons, elsewise you'll get a compilation error whenever you try to compile and upload to your board. All right. So we'll just say that this sets the font. So here's the fun part where we draw strings to our display. So once again, we're going to say U8G2. Do you see why I copied it to my clipboard now? I don't want to write that all the time, and I imagine you don't want to either. So using the U8G2, we're going to call on a method called drawString, draw str. Whoop, not sraw, draw. There we go. And we're going to open parentheses. And inside this is going to take 3 parameters. The first one is the x coordinate, the second one is the y coordinate, and the third one is the string we want to type. Okay. So to start off with, I'm just going to have it draw on the 0x coordinate. We're going to put it on the 24 on the y plane, on the y coordinate, or axes, if you will. And then I'm just going to go with the generic hello world. Let's throw a comma in there, because technically it is a dependent clause with the world. All right, cool, there we go. We'll cap it off with a semicolon, go down one more line, and we're going to do the same thing again. I'm just going to copy and paste this line. And I'm going to change my 24 to a 44. So it's going to be 20 pixels below hello world. I'm just going to say, what's up? Let's do it all lowercase. Uppercase is kind of aggressive. What's up? Cool. So this just draws the text on the OLED at a specific coordinate. Easy peasy. All right, cool. We're going to go down to the last line, line 16. And what we're going to do now is we're going to take this and send it to the display. We're saying, hey, here's the memory that I want you to keep into your display until it's changed. So we're going to, once again, let's see, I'm going to highlight this bad boy. Control C, and then Control V once again. And we're just going to use a thing called send buffer. And that just does what we talked about. It sends this to the board. So sends buffer to display. All right, and after a quick check, make sure that we're not missing any semicolons and there's no undeclared variables. All right, so now let's go ahead and click upload. We see it writing to the board, and then look at that. Hello world, what's up? And just like that, we've set up, coded, and written to the OLED. Now, I do have a more in-depth or more extended tutorial on making a game with this OLED coming up. Stay tuned for that. Probably, I'd say anywhere from 4 days to a week out. So that was recommended by one of the viewers, who I will name in that video. Anyway, if you guys have any ideas for videos, be sure to drop them in the comments, leave a like, and subscribe if you're not. There will be more stuff like this coming soon because I have no life and I love electronics. Until next time, I'll see you.